how would we begin to analyze different algorithms? For that, we really need different performance metrics. So let's imagine that you have an algorithm which provides a correct solution to a particular problem statement. Then that algorithm is subjected to different types of input instances: I1, I2, I3, I4, I5, where I1 is just input instance 1. And we run this algorithm on these input instances and we see how much time the algorithm actually takes to execute. Then we plot the runtime versus these 5 different input instances and we highlight the best case, the worst case, and the average cases. Let's consider the best case input. You'll clearly get the best case runtime. But think about the real world. Is the real world only or primarily going to be based on best case inputs? The answer is clearly no. Let's consider the scenario of the average case input. This will clearly lead to a sort of an average case runtime. But what really is an average case, given that the average case is just sitting sandwiched between the best case and the worst case, and the average case input can and will keep changing over time? Let's consider the case of worst case inputs. When you have worst case inputs, then clearly you will get the worst case runtimes. But just think about it. As your algorithm gets better as it operates on worst case inputs, then in the real world, as it gets a variety of inputs ranging from the best case to the worst case, then the net performance of that algorithm will actually keep getting better. Let's give a slightly relatable example, something that we can, almost all of us can sort of relate to. So imagine that you were an athlete, and in particular, you were training to be a 100-meter athlete, right? That's your specialization. Then surely that's not the only environment that you will train in. You will train in all sorts of environments. You might sort of decide to run along a highway. You might decide to train in a very rough terrain. You might actually decide to actually climb a mountain or run along mountains. Now, essentially, as your performance starts to get better and better in the worst of conditions, then on the whole, you will start to become a better athlete. So in a very similar sort of way, as your algorithms get better and better in the worst possible inputs, then under real world considerations, you would expect that your algorithms will on the whole start to perform better and better.